Hello everyone. From today onwards, we will be studying scada. Means like what is scada, what are all the things are there in a scada. So how to design scada and how to work with the scada things and all. Okay, so basically scada is an acronym for supervisory control and data acquisition. Okay, so what is its meaning? Okay, basically you can see here. So control and data acquisition is there. Okay, so control anyhow we know. Okay, so let me explain brief about this data acquisition. See, data acquisition in the sense normally one thing will come to our mind, that is data collection. Okay, but data acquisition means not only data collection. Okay, so but for a best example I can give you is we have one boiler. Okay, so that operating parameters I need to monitor in the SCADA. Okay, so boiler means like temperature will be the most what I can say means temperature is the important factor that we need to monitor. Okay, so usually we will be using some temperature sensors and all. Okay, so which is going to measure, let's take an example of 0 to 1000 degrees centigrade. Okay, so in SCADA also like we will be showing so same exact value only 0 to 1000 degrees centigrade. Okay, so in between you will be having controller because all your field devices are connected to the controller only, not to the SCADA directly. Okay, but your sensor uh, is giving what I can say output in terms of temperature, right? Okay, means like it is going to measure only temperature. Okay, so sensor means it will only sense, means yeah, it is only sensing. Okay, it won't convert or it won't detect or it won't trigger anything and all. It will only sense the physical parameter. Okay, so now input for your sensor is temperature. Okay, but if PLC want to read that signal means, okay, so directly I can't give the temperature. Okay, so the temperature means physical quantity. I need to convert it into suitable electrical signal such that your PLC can read. Because so if it is an analog means your PLC will be able to read only either a voltage signal or a current signal. Okay, so now what we'll do, so if we are having a sensor with a thermistor and all means, so if the input is temperature means, okay, so in between we will be having a transducer which is going to convert that physical quantity into electrical quantity, means that temperature into suitable electrical signal. Okay, either it may be a 0 to 10 volt voltage signal or 4 to 20 milliampere current signal. Okay, means what is the process here? First what we'll do, we will be getting raw value from the field device. Okay, then we will convert it into suitable electrical signal such that your PLC can read. Okay, again what we'll do, that 0 to 10 volt we will scale with the actual raw unit what we are having to monitor in the SCADA, means to display in the SCADA. Okay, so here two things are involved. First one is acquiring the data from the field. Next one is scaling it or like working with the data. Okay, so for what? For monitoring purpose or for storage purpose. Okay, so for further applications and all like this. Okay, so total, so what are all the tasks that we are doing with the data what we are getting from the field, that totally called as a data acquisition. Okay, data acquisition in the sense collecting the data, scaling it, okay, and like making it means in a proper way that I can monitor or I can store or I can use for like further applications also. Okay, so this is one application. Next one is supervisory control. Okay, means so what and all we are doing, we are controlling also and we are monitoring also from the data what we are getting from the field. Okay, so this is just what some brief introduction about SCADA. Okay, so anyhow we will be knowing the definition and all. Before that we need to know what is that SCADA meaning. Okay, so here we have an introduction for that. You can see SCADA system is a common process automation system. Okay, so which is used to gather the data from the sensors and instruments located at remote sites and to transmit and display this data at a central site for control or monitoring purpose. See, this is very simple. So SCADA is the most widely used tool in process automation field. Okay, so why? Because okay, to gather the data from the field devices. Field devices, it may be anything it may be a sensor or any instrument such as IED, it may be, or it may be a controller like PLC or RTU, okay, or it may be a switch, anything it may be, okay. Means you will be gathering the data from all those field devices, okay. After gathering, okay, what you will do, you will transmit and display that data at a central site for control or monitoring purpose. Means, so actually if you go with the larger scale industries and all, okay, so site will be somewhere else, but the control room will be like some distance will be there. Sometimes it may be like very far, like where we can go with the wireless connections also, okay. At that condition I can go with this application, okay. So your field devices will be in the remote locations. So SCADA you are using to gather the data from that instruments which are located at a remote distance, and that you will be sending, okay. So for some what I can say remote sites and all, okay. So at a central site we are calling it as for what purpose? Controlling or monitoring your field devices. Next, the collected data is usually viewed on one or more SCADA host computers located at the central master site. See, you are having one site, okay, so remote distance only we will take. So there also you can monitor in one some host computer, and it can be monitored in the remote site. So what I can say computer also or master system also, okay, in the remote site. Means the same process you can see in a multiple, means how many devices you want to connect, you can connect and you can see what is its status. So here locally I can see, or like somewhere I like what I can say that client will be there, he can also see what is happening, or like owner will be there, okay, in remote locations he can also visit what is happening in the sites and all, okay. Next one is a real world SCADA system can monitor and control hundreds of thousands of IO points, nothing but the SCADA can most widely used for larger scale industry. So where I will be having some thousand number of IOs and all. Okay. So next, the term SCADA was coined in 1970s. Okay. So SCADA is like what we are having advanced now. Okay. So which like it got its name during 1970s. Okay. So before that, like what we used to call SCADA. Okay. So SCADA like is called with the name called as telemetry. Okay. So why? Because remote data gathering as telemetry, okay. See, remote data gathering, the term is you are calling it as a telemetry, means tele, okay. The word telemetry is divided into two halves, that is tele and metry, okay. Tele stands for remote, okay, means from certain distance, like that, okay. Metry means data gathering, okay. So combinedly we are calling it as a remote gathering, which constitutes the word telemetry, okay. Means previously SCADA name was telemetry, now it is renamed as a SCADA, okay. Fine. So next we'll see, okay. So now we are in advanced level of SCADA. So before that what and all was how we used to monitor and control the things, okay. So that we'll see, that is nothing but evolution of SCADA, okay. So you can see here, this is what I can say, the olden days SCADA what we had. Okay, so we named it as mimic panels. So panels are there, so on which several what I can say meters, knobs, and some CBs or some LEDs, push buttons, all are mounted. Okay, so keep it in mind one thing, all these devices are okay directly wired from the field devices only. Means all are like wired, through wired it is connected, okay. So this is what the mimic panel, okay. So next what we are having is, so all these things we replaced with some small software, okay. So this is what the advanced SCADA what we are having now, okay. So this is mimic panel where all the IOs are interconnected through wiring, okay. So this is using this panel we used to monitor, and if it is necessary we will be controlling here. So now what is happening, so we have software, okay. So this we replaced with some software, okay. Now we'll see what are all the advantages and disadvantages of the mimic panels and the software what we are having, okay. Fine. So this is how the exact mimic panel was. So just I took one small sample. You can see here sensor, here it is representing the field devices, okay. Either it may be a sensor or it may be a push button or it may be anything, okay. So or you can consider like output also, either it may be a valve or it may be a motor or a pump, anything it may be. Okay, so this I'll consider it as a field IO, means input and output. Okay, see, as I told, all the inputs and outputs are hardwired like this. Okay, so you can see either like this may be some two digital sensors or it is digital outputs. Okay, you can see it is connected to some LEDs, and these two are like analog sensors which are connected to some gauges and all. Either it may be a pressure or a humidity like this. Next again some sensors are connected to some trench panels and all. Like this all the things are hardwired. Okay. So this mimic panel, what advantages it have, we'll see now. Okay. So you can see here, it's simple. Okay. So and it was not having any CPUs, RAMs, ROMs and all, and no software. Okay. So because everything was like mechanically designed and electrically hardwired and all, so that's why like we don't need the software, and programming and all was not needed. And sensors are connected directly to the meter switches and lights, so on the panel. Okay, so that again software, graphic designing and all was not required. Okay, and it could be easy and cheap to add a simple device like a switch or indicator. Okay, so this point usually refers to, means I can, it will be very economical and easier for small scale industries where we'll be having the IOs like less than 250, 300 like that. Okay, so next, what are all the disadvantages that we had in the mimic panel? Okay, so the amount of wire becomes unmanageable after the installation of hundred of sensors. So the main disadvantage, that is common thing. It's not suitable for like medium or large scale industries. Okay, because as the IO number increases, obviously the wiring is going to increase, which makes the circuit very complex. Okay, as a result, what will happen? Okay, they again like you can see here, the quantity and type of a data is minimal and rudimentary, nothing but like less number of IOs, means again like if I have more number of IOs, again I need to go with the designing of one more mimic panel. Okay, means very less quantity of data I can monitor and control from the mimic panel. Okay, so installation of additional sensor becomes progressively harder as the system grows. Okay, as I told, if you want to extend your mimic panel, see now I designed one mimic panel where I connected some 15 to 20 meters or some 100 LEDs and all. Okay, so suppose if I want to add some 20 more or 50 more means, so it will be very difficult to what I can say extend its application. Okay. Next, reconfiguration of the system becomes extremely difficult. Okay, nothing but troubleshooting will be very difficult. If I want any modification, that was very difficult to achieve in this phase. Okay, so one more main drawback is simulation using real data is not possible. Okay, so now what you are doing, like you have WPL soft, which is a software means used to what I can say program the delta PLC. Okay, so you have software now. What you will do, even if you don't have controller with you, you will turn on the simulation and you will start programming it. So just like you are programming an virtual controller. Okay, so this is one of the advantage of software. Okay, say suppose instead of like software, so the hardware system we have, that is relay wiring. Okay, so can you simulate relay wiring? No, you should have hardware for that. Okay, so this what exactly replicate here. Okay, since like we depend on like hardware and all. Okay, so simulation is not possible here. Okay, because if you want to simulate, we need to have a software which is not present in this. Okay, so this mimic panel. Okay, next, storage of data is minimal and difficult to manage. Okay, so what is happening in these mimic panels and all, if I want to store the data and all, so I can go with the manual type of, or maybe some data loggers were there in that time. Okay, but the what is the frequency of the data, frequency in the sense per minute we are getting, or per, like for each and every 5 minutes or 10 minutes. Okay, that precision was very less. Okay, and we can't store much data also, as it was not having any advanced applications. Okay, like ODBC or wireless communication with various servers and all. Okay, that's why not much effective, that data logging and all. Okay, no offsite monitoring in the sense, see mimic panel is somewhere in the X location. Okay, if I want to monitor and control means I should be in that location only. Okay, so apart from that, like anywhere from the remote location, it was not possible. Okay, That was one disadvantage. And again, like same as in the manual system, we always need someone to watch that mimic panel, means to monitor or control all the 24 hours of a day. Okay, so again, it was not a easier task. It's a main drawback. To overcome that only, we are moving for the next phase. That is what SCADA system. Okay, so basically SCADA is what? So as I told, the main purpose of SCADA is to monitor and control the field process. Okay, that is what the function. But what is SCADA basically? What it consists of? Okay, so we all know SCADA is a software application. Okay, but to run that SCADA software, okay, we need to have some user interface devices. Okay, so that I can call it as an industrial PC, or you can go with the PC also. Okay, and if I want to tell it as a complete SCADA means I need to have a controller which is connected to it. So controller means I need to have a field inputs, outputs, or I need to have sensors, or I need to have intelligent electronic devices. Okay, and for networking and all, I need gateways, or I need routers or radio transmitters like this. Okay, various hardwares also it constitutes of. Okay, so combinedly what I can tell, so your SCADA system consisting of both hardware and software. Okay. So you can see what are all the hardwares we are using here, and software, depending upon the brand we have what I can say different software, that we'll see what are all the SCADA softwares we have. Okay. So now what's the definition of SCADA? SCADA is a system comprising of both hardware and software. Okay. So which helps an industrial organization to control, monitor, process, and analyze the real-time data acquired from the field devices. Okay, means it's a hardware which is having its own software. Okay, or software like to which means to run that one we need a hardware. Okay, so which is used by the industries. Okay, so for what purpose? To control, monitor, process, and analyze the real time data what we are getting from the field devices. Okay, so this is what SCADA definition. Now we'll go to what are all the advantages and disadvantages of SCADA what we are having. Okay, so first point is reliability of a system. Okay, means it is increasing in SCADA, they are telling. First we'll know what is reliability. Okay, reliability is a very important term in like almost all the fields. Okay, see, reliability, that, so how much we can trust that system. Okay, means if anything happens, or like if any system goes to repair statement, how fast it will recover. Okay, means like whether it is recoverable or not, how fast it will recoverable, so how much time it needs. Okay, so basically that repair time we are calling it as a downtime. Okay, so here reliability is more in the sense, okay, that downtime will be less, means repair time will be less, suddenly it will be available for the next operation like that. Okay, so reliability is more means downtime will be less. As a result, what will happen? Obviously your production rate is going to increase. Okay, and next, excellent graphical user interface. Okay, so to explain this one, I'll just go back for the previous slides. You can see here whatever the field devices you had here, that all those things just you are representing in a small graphic format, that too the multiple colors with the labeling, and that's rating also you can display here itself. Okay, so this what explained by this excellent graphical users. Okay, next, what point is there? Various forms of report generation, also representing the data, that you will come to know how we will be representing. So the what I can see, the data what I'm getting from the SCADA, I can represent in form of Excel sheet, or I can represent it in form of Word or a notepad, or graphically if I want to represent, I have some trends. Okay, or I can represent it using bar graph or a pie chart. Okay, so like these various forms of the means are they to represent the data what I'm getting from the field. Okay. Next, data logging and recording. Okay, data logging in the sense again like storing the data whatever I'm getting from the field. So here SCADA facilitates you to what I can say, fetch the data for each and every millisecond. Okay, so that much precision it is capable to means it is capable of giving. Okay, So very like highly advanced techniques are involved in this, and I can increase the storage how much I want using some cloud applications and all. Okay, like this. Next, so like if I want to communicate with other devices or other servers and all, okay, so it is going to support various protocols, okay, but its application is not limited. Again, using the driver, almost all the types of controllers or almost all the types of drivers I can communicate with any SCADA. Okay. Next, maintenance cost is obviously less. Analyzing of data in the sense, okay, so that only as it is suitable for remote applications. Okay, so what happens? Either for remote or for local also. So you are getting the real time data, and you will be having what I can say, the previous data also. So from the data loggers and all. So what you can do, can analyze. So day before yesterday, so at this time this was the production rate, okay, and today this is the production rate. So what's the difference? So what is causing it? Okay, how I can improve it? Okay, that easy, like because we'll be having various data formats and all, and we can analyze it very easily. Okay. Next, disadvantages of SCADA. So this is quite common. Initial cost will be very high, and it will be creating that unemployment rate and all. To design or to work with the SCADA, okay, and to do the communication and all, we need some skilled person, means trained person. Okay. Next, we are like mostly depending upon here machines and all. Okay, and that's the disadvantage. Okay. See now what the SCADA we are having, the advanced. Okay, so basically it is having three generations. This is the evolution of modern SCADA. Okay, fine. So we are having three generations, first, second, and third. Okay, so first generation we are calling it as a monolithic. Second generation we are calling it as a distributed, and third generation we are calling it as a network. Okay, so I'll explain you in brief what are all these things. You can see here, monolithic SCADA means you'll be having only one SCADA master which is connected to the multiple controllers. See, these are remote terminal units. So, in the sense, these are like controllers also. So, which is connected to various controllers or various field devices. Okay. So, means this is the source of the data what we are getting from the field. Okay. So, which is connected for your SCADA master. Okay, through the WAN. Okay, WAN you can use a fiber optics, or I can go with the satellite communication also, like this. Okay. So only one SCADA master will be there. So if I want to communicate these two, so it is coming through like this, and it is going like this. Okay, so like this. So means, so we are working with the single point. Okay, that is what monolithic means. Only one SCADA master was there. Okay, fine. Next, distributed SCADA. You can see here, just leave this part. This part remains same. Here I can see I have multiple operating stations. So in the previous, I had only one SCADA master. See here I have multiple operating stations which are connected to a hub. Okay. Hub is connected to what? Okay, this communication server. So again, communication server is a point of contact for all your remote controllers. Okay, means I can monitor from here also, or I can monitor from here also, here also, here also. So multiple SCADA stations we had. Okay, that is what distributed SCADA. Next, network SCADA. This is the advanced what we are having. See, I can directly means, so here almost it is a wireless communication and all. Okay, so somewhere the SCADA master will be there. Okay, so somewhere the RTUs will be there. Okay, so I can, what I can say, receive it at the remote location, so here RTU will be there. I can go with the communication server to the cloud and all, or directly I can connect if I'm having the network properties with the RTU. Okay, that I can fetch wherever I want. Okay, here I need some ports, protocols. Okay, wherever the communication comes, so there will be a port, and like some set of rules will be there, that we are calling it as a protocols. Okay, which protocols it will support, we'll see later. Okay. So these are the three different generation. You can study in brief later. It's not much needed now. Okay. Next, we'll see what are all the features of SCADA we are having. Just I list it here. Okay. So first one is user interface. Next one is graphic display, alarms, okay, trends, okay, networking, okay, report generation. Last is recipe management. Okay. So like totally seven features are there. We'll see one by one. So first one is user interface. You can see here, as I told, SCADA is a software, so which is going to look like this. Okay, but to work with the software, I need some hardware such as like I need a keyboard, or I need a monitor, or I need a CPU with the RAM, ROM, and processor, all those things. Okay, I need to have a mouse, or it may be a printer, what I can say, that printer and all. Okay, so like I need some what I can say, hardware devices. Okay, means so using these user interface devices such as keyboard, mouse, monitor, and all. Okay, so I can create the SCADA, okay, according to the user, means how he need, that means in that way he can create using this user interface devices. Okay, next, graphic displays. So you can see it is telling it is customer configurable, nothing but user defined. Say suppose I have one switch. See, I can represent it how I want. Okay, so what color I want, what graphical feature I want. Okay, where I need to place that one, how I need to name that one. Okay, like this, user can define his own SCADA according to the field device what he is having. Okay, object oriented and bitmap in a sense, again like you'll be having images and all. Okay, object oriented means, so switch means like particular graphics will be there related to switch, you can drag and drop. Okay, all these things means you will be having multiple options for this graph, what I can say, graphics. Okay, next one is unlimited number of pages, in the sense, see, like if I say an industrial SCADA means there will not be a single screen. Okay. So means according to that what I can say, plant design and all, you will be having multiple screens. Sometimes it will be 10 or 15, 20 like that. Okay. Means depending upon the application, you can create how many SCADA screens you need. Okay. So I'll show you how SCADA screen and all it will look. Okay. But just get to know about it this. Okay, next, maximum resolution in the SCADA screen I can give up to 12802 to 1024 pixels. Okay, with the million number of colors. Okay. This is about the graphic displays. Next, alarms. Okay, so alarm is a very important term in industry. Okay, so basically what is alarm? Okay, I'll take one example to explain alarm. See, I have one tank, means the process is like tank filling and draining process. Okay, so I will define that the tank capacity is 1000 liter. Okay, so if I start to fill means, okay, so I should fill below that 1000, or it should be equal to 1000 liter. Means my set value is 1000 liter. Okay, process value will be less than or equal to that. Okay, so if it exceeds the 1000 liter means, then what will happen? It's not an healthy condition of the system. Okay, so I should get some notification and all. Okay, means I should generate some event that is going to trigger some particular things and all. Okay, like that something should happen if the process value exceeds the set value, means some events are going to generate. Okay, that is nothing but here alarms. Okay, how can I define the alarms? Okay, it's an event which is generated. Okay, so when, so the process value exceeds the set value. Okay, so this is about the alarm. So client server architecture, in the sense how you want, again it is a user defined. Okay, so at what condition you need which alarm. Okay, so low level alarm, high level alarm, or rate of change alarm, like this. Okay, how you want you can define the alarms. Okay, next, time stamped alarms for 1 million second precision, means if anything is happening, means like at what's the time now, like 28 minutes one alarm popped up. Okay, next point 1 millisecond only, so it can generate one more alarm. Okay, that much like a better quality of time if it is maintaining. Okay, next, single network acknowledgement and control of alarms. So obviously we know if alarm is popping up means I need to acknowledge it. Okay, so means by acknowledging I'm telling that system that yes, I got to know, I got the message that alarm is popped up. Okay, so I acknowledge that one, in the sense I'm trying to solve it, or I tried to solve it. Okay, or like I got to know the information, like that some indication you are giving for the system through acknowledging. Okay, that option is also available. Next, event triggered alarm, in the sense, so any emergency turned on. Okay, that is one event. Okay, at that condition also you are going to get one alarm. Any CB is stripped. Okay, that is one event. Again you are going to go. Again you are going to get one alarm. That is like event triggered alarm. And all the alarms. Okay, so you can have it in the form of a report. Okay, so in the form of a Excel sheet you can get it. Okay, Next you have operator comments can be attached to the alarm, means in the sense each and every alarm you can write your own message. Okay, that also I'll show you how to do. Okay, so we'll go with the next feature, that is what trends. Trends is something, it will look like this. So again, so if I want to give one example, so all of you, like we are aware of the ECG machine, so electrocardiograph, which we are using to what is a sense that, or like to measure the heartbeat or a pulse rate like this. Okay, so what is happening inside the body, that is different. Okay, we don't know that process, and means we know, but how it is taking place no one knows. Okay, but what is that machine is doing, whatever the process that is happening inside the body, that it is going to represent in the form of some xy graph, right? The same thing here also. Say suppose if the tank is filling in the field, okay, I can get a graph like this. If it is draining means I can get a graph like this. So that is what here trends. Okay, means it's a graphical representation of the field device or a field process. Okay, so whatever the trends you are getting, so with respect to that particular time, see suppose now 0, so you are having four sensors here. Okay, one is 10, 12, 15, 20, like that means, so what's the value for the 0 second or 10 second, 5 second, 20 second. Okay, all those data I can transfer it to some excel sheet, or I can transfer it to some open database connected. Okay, so dbf means it's a database file. Okay, so it may be a sql or it may be a microsoft access like this. Okay, I can transport there. Okay, again like xy features are there, so according to the events it can generate, you can, means some changes you can do in that trends page also. Okay, that will, these things will I'll show you. Okay, so again you are having two types of trends, real time and historical trends, that also we'll get to know once if we start this SCADA software. So this is about the trends. Next we have networking. So like we have seen, okay, so in the distributed SCADA and this networking SCADA, we have something called as a communication module. Okay, so that is one type of networking. And if I want to operate for like local devices also, if I want to connect for any controller, means like if I want to install a SCADA software, means that time also I need to check, okay, whether it is supporting Windows or not, whether it is supporting Mac or not, like that. Okay, so that's what, like everything comes under one networking. Okay, so wireless or wired or software, the PC, what requirements it should have and all. Okay, so it supports all the net basic input output service and all compatible networks such as network LAN manager and all. Okay. Next, it will support Windows type of work groups, Windows NT and all, and it is going to support various protocols. So centralized alarms and report processing data available from anywhere. Okay, if it is connected to the network means. So either it may be a remote or a local, or it may be a wired or a wireless like this. Okay, dual network for full LAN redundancy, means it is a duplex system. Okay, fine. So next we have report generation. As I told, I can generate the report in these different formats. Okay, so you can see here. Okay. So next one is recipe management. See, recipe management is something. Okay, so what example I can give you is, if you go to some malls and all, so there will be some vending machines will be there. Okay, so let's take some coffee or tea vending machines, or like some ice cream vending machines. Ice cream it is manual, let's take some coffee and tea vending machines. Okay, so there what, so some single chamber will be there, or some single cabin or some box kind of a thing will be there. So you will be having two channels there, like one is for tea and one is for coffee. If you press tea, you're going to get tea, and if you press coffee, you're going to get coffee. Right? So how it is happening? Okay, how the things are, how tea is preparing inside, how coffee is preparing inside. Okay, so like this, how it is happening. This is one very small example. Okay, I will tell you like while doing, but just get to know what is recipe management. Okay, so here they are explaining with one example that in many cases, we use the same plant for manufacturing different products. Okay, means in the same industry, if I want to manufacture the different products, such as they have given one example also. So same industry we will be using for what I can say to manufacture. It's a oil blending plant, can manufacture power oil also, transformer oil also, and automobile oil also. Okay, so maybe the raw materials what we are using for these three, so some of the items are similar, then so some of the items are like different. So how we are working with the industry, if the same industry is manufacturing multiple what I can say things, means how we are working with the items what we are having. Okay, that and all is defined by this recipe management. Okay, so the recipe management is a facility used for maintain various recipes of different products and implement it on the process. Okay, means so what we are manufacturing, that is we are calling it as a recipe. Okay, so to create the recipe, whatever the things we need, that I will call it as a items. Okay, so in the sense, so in a same industry, they are manufacturing different recipes using similar or different items. So how to work with these things are defined by this recipe management. Okay. See, once if you define a recipe for that industry, means so you can, means a client can fetch it from the remote locations also. Okay, to run the same recipe in the other industries also, that I can transfer also once the recipe starts working. Means okay, this is what recipe management. Okay, so this is the last feature I think. Next we'll see typical scada system. Okay, means scada system architecture. Okay, so if you go here, so in summary, there are five major areas or components to the SCADA system as listed below. Means if I am going with the SCADA architecture, there are five different levels. Okay, so what are all those? We'll study in brief now. So first one is field devices and signal. Next one is programmable process controllers. Next one is SCADA operating sections, SCADA server section. Next one is communication network. Okay, I'll show you one picture which will explain all these things in a better way. Okay. So this is how your SCADA architecture looks. Okay, you can see here five different levels are there. So level 0, 1, 2, 3, 4, 5. We will start with the layer 0. You can see here layer 0 consisting of the different controllers. Okay, so such as PLC, or it may be a RTU also. Okay, so as I told, see, always your field devices are connected to the controller, not directly to the SCADA, okay, or directly to the HMI. Okay, so it's always connected to the controller, whereas your controller is connected to the HMI or to the SCADA stations like this. Okay, so you can see here. Okay, so all the field devices are connected to PLCs here, PLCs or RTUs, or combinedly you can call it as a controller. Okay, so all these are connected. Okay, so towards some, okay, so device stations. Okay. See, like layer 1 controller LAN is there. Why? Because if you go with the small scale industries, so like some 50 IOs are there, means one controller will be there, you will connect all those to the PLC, so there only you can have a system. But if you are having a larger system, means why? Because so SCADA in the sense it is suitable for larger scale industries. Okay, that's why. Okay, so I will be having some 4 to 5 what I can say slave devices, means slave PLCs will be there. Okay, so some, yeah, like that. Okay, but I need to connect all those things. Okay, that's why I'll be using this switch or a hubs or a routers, all those things. Okay, so all those, or it may be a what I can say your interface modules also. Okay, so all those I will integrate it to like interface modules like this. Okay, this is what the controller LAN. Okay, so either it may be a Profibus switch, or it may be a Profibus, or it may be a repeater, or Profinet switch it may be, or it may be a Ethernet switch, anything it may be. All those means hubs we are creating here for the controller. Okay, so from that hub we will be connecting it for a system. Okay, so system, so where for the this panel I can have a HMI here also. Okay, so this is what the system. Okay, here only I can design my own, means I can monitor, means here only I can have a SCADA also, or I can design my own HMI. Okay, like this. Okay, this is what I can say supervisory LAN. Okay, so this is where exactly, means this I'll call it as a SCADA operating system. Okay, this phase. Next I have operation DMZ. Okay, DMZ in the sense demonetized zones. Okay, so means where all these things will be monitored separately using many devices. Okay, so which are connected to firewalls and all for safety, all those things. Okay, so this is what the actual SCADA workstation. So if you want to extend the application of your SCADA, like connecting to the internet or connecting to the multiple devices and all, okay, so historian and all if you want to do, okay, so then you can go with the layer 3, okay. From there it will go to the client side and all, okay. This is for what I can say, local in the sense, again up to here it is what, wired connection, okay. Again, so layer 5 is for internet. This is for extremely remote application, so which is happening through wireless, okay. This is what SCADA. So this is field level. So what we have seen, okay. So just I'll go back to the previous slide. Okay, see, field devices and signals was there, right? Okay, and programmable process control was there. Okay, so those two layers here it will come here. Okay, so which is the bus network. Next, what I have, okay, so next I have SCADA operation or a user workstation. Okay, so this is what a SCADA operation or a user workstation. Okay, then I had SCADA server computer. Okay, so this is what your say SCADA servers, computers, all those things. Okay, next again what you have here, sorry, communication network. So that's what I'm having here. Okay, this is for web server, email applications, so for remote users, all those things. So this is what the architecture of your SCADA. Next, just I'll show you an example of power plant. Okay, so this is the best SCADA example for your power plant system. Okay, so here I'll be having RTUs and all field devices. You can see field devices will be there, either it may be analog or it may be a digital. Okay, so here I'll be having RTU. Next I have communication system. Communication system, like so you will be having sometimes a Profinet or a Profibus or some Ethernet and all those things. So here I'll be having, you can see here, this is what the SCADA workstation. Okay, so for all these things I'll be designing the graphics where I will be monitoring and controlling it. So like some subsystems will be there like servers and all. So here I have a master station, so where multiple servers and all I will be having it. So this is for like commercial, for the higher level and authorities and all, they can use the data from here, okay, for processing and all. This is one example. Next we'll see, as I told, you can see here field devices, different controllers. Okay, so if I want to proceed further means, see here, if I want to go up to here, here and all means, I need to have a various protocols. Okay, either it may be a Modbus, ASCII serial or a RTU, TCP, IP, or sometimes it may be a Ethernet or some IEC standard. Okay, dynamic network protocol, IEC 61850 is the most widely used. LonWorks BACnet is for building management system and all. Okay, DTE is SNMP, Profibus, Profinet, HTTP, like these various protocols. So like it is going to support for the communication with the other devices. Okay, so these are the protocols what SCADA can support. Okay. Next, what are the different brands of SCADA we have? SCADA brands in the sense SCADA software only. Okay. So first one is iFix from General Electrics. Okay, iFix stands for Intellusion Fix. Okay, so this is one of the brand. Next one is RSV32 from Rockwell Automation. So what the ABPLC we are using, no, that is also from Rockwell. Okay, so that Rockwell Automation SCADA is RSV32. So this is what I can say product of Rockwell. This is a parent company. Like this, GE is a company which is having its own SCADA software, that is iFix. Next, KingView, it's from Well Intech. Okay, next one is Aveva InTouch HMI. Okay, so oftenly called it as like Wonderware InTouch. It is from Schneider Electric. Next, we have WinCC from Siemens. Okay, these are the most widely used, means like popular brands. Okay, so but we have some other brands also. Means in our lab we are going to teach these five. Okay, so now in SCADA class we will be learning these four. Okay, means iFix, RSV32, KingView and Aveva InTouch. Okay, WinCC you will come to know when you start with the 3 months and all. Okay, so other brands also we have, that is PCView. Okay. Next, Reliance SCADA is there. Okay. DiaView is also there. Factory Talk View, again it is from Rockwell Automation only. DiaView is from Delta. Ignition SCADA is there. Okay. So these are the few brands what we are having in SCADA software. Okay. So next one, we'll go with the communication of your SCADA with the controller. Okay. So that is what interfacing controller with the SCADA. Okay. Means, so SCADA software means, as I told, it should be integrated with the controller. Okay. So here you can see it's a Delta PLC. Okay. So as I told, Delta PLC's SCADA is DiaView. Okay. So DiaView is the SCADA of your Delta brand. Okay, so always your field devices will be connected to the controller. Controller will be connected to the SCADA system. Okay, so what it is telling? Oh, sorry. Uh, just a second. Okay, so we are dividing this interfacing of controller section into two sections. Okay, means communication with the controller we are have means we will get two scenarios. Okay, one is interfacing of same brand PLC and same brand SCADA, so like how I am having here. Next one is interfacing of different PLCs and SCADA, nothing but two scenarios. One is communicating SCADA and PLC which are from the same brand, like this Delta controller and Delta SCADA. This is one scenario. Next one is interfacing your what is a Delta controller with some other SCADA. Either it may be a InTouch or it may be a WinCC or it may be a iFix, like this. Okay, two scenarios. So what's the difference we'll see now. Okay, first we'll go with the same brand PLC. See, if I have the PLC and the what I can say SCADA same brand means directly using some communication protocols and ports and all we can communicate. Nothing but these are the two known devices. Just like the two persons which like who is knowing the same language like English, how we are communicating. I know English like you are also knowing English. So directly we are communicating without any translator and all. Okay. So same way if I am communicating with the same brand means no need to have a driver and all. Okay, fine. So but if I am interfacing with the different driver means now see I have Delta PLC, but the SCADA what I am having is Schneider Electric, that is Aveva InTouch HMI. Okay, so if this is the condition means that whatever I am speaking that language you don't know. Okay, because you are from the different states or a different country. Then what I need to have some translator kind of a thing which will be exchanging the information between you and me. Okay, so that's what here in the communication we are calling it as a driver. I hope you know. While inserting a new device to your system, okay, so your device will not be knowing what is that. So every time you just plug your mouse and all. Okay, so device found, device driver found, device driver not installed. Okay, so driver is nothing but which will exchange the information between the two unknown devices or two unknown things. Okay, so like this if I want to interface my controller with the different brands of SCADA means I need to have a driver here. Okay, so again this is a different topic that you will get to know in the future slide, but you should know these things. Okay, so same brand Delta, same brand PLC controller and like SCADA if you are having no need to have a driver and all. Okay, if you have the different brands of controller and the SCADA then you need to have a driver or a gateway, anything. Okay, fine. Next what we have is, okay, so like this I can interface if I'm having a driver of that particular controller. See, if I have Delta IO driver I can communicate Delta PLC with the Schneider SCADA software. If I have a Siemens driver again I can communicate. Okay, so any SCADA I can take here. Yeah, even like Delta PLC I can communicate with the WinCC if I have a proper IO driver communication model and all. Siemens I can what I can say communicate with RSV32. Okay, AB I can communicate DiaView or I can communicate with the any other SCADA brands if I have a driver means. Okay, fine. So Kepware features, why I added Kepware here means, see, Kepware is the most widely used OPC. Okay, why? Because so almost all the control drivers are installed in one software. Okay, see, so instead of like various drivers, if I have one Kepware here, I can connect any brand of PLC to any brand of SCADA software. Okay, so that's why they are given the features here. You can see here, this is the basic level what we are having. This is what I can say, advanced one. Okay, but you should know, okay, what and all it will support. See here, I can connect, means drivers will be there one at one end. So here you will be having that kept server APIs and all. Okay, so my end device may be this one. Okay, so I either I can go with the OPC or MQTT. For what purpose? Again, for the HMI or SCADA I can send, or for database, or for any other applications. Okay, this is how it is converting. Means whatever the data you are getting from the PLC, that supporting drivers will be there in the base level. So that suitable conversion API has been written in the KEP server. So it will make the data whatever you are getting here. So it will convert it into suitable form such that you can operate these devices at the interfacing side. Okay. So KEP server is one of the software what we'll be using, what I can say, to convert your this one, means the different the data what you are getting from the different bands. Okay, so which you want to connect for the different brands of SCADA. Okay, so as I told, you can see Matricon is also one of the software. So this is IO gateway or OPC. I told any brand of controller I can connect to any brand of SCADA. Okay, and I have multiple options also. I can go do the gateway operation, web publishing and all using several dashboards. Either it may be a Node-RED or it may be IoT things. Okay, so like this. So next, you can go for the gateway also. Okay, so like this you will be having hardware gateway also. Okay, so KEP server, sometimes you need wired and all, wireless you can go with the KEP server. This also used, means this is what I can say, industrial kind of a thing, industrial IoT gateway. Okay, so see, this KEP server and Matricon is a software. Okay, these are not the hardware. So this is what same application, but it is a hardware like this. Okay, next, so how it is going to work and all. Okay, so here they have given, just you can go through with that. Okay, so now we'll, up to now we studied, so what is SCADA, what and all comes under the SCADA, means architecture. Okay, how to communicate with the controller and all. So from now we will be studying how to design SCADA, means how, like SCADA software we will be studying. Okay, so nothing but SCADA software features. Okay, so basically, SCADA software, no, okay, it consists of, so means like SCADA software means you will be opening a first new project you will create. After that, new project in the sense, so that's like it's a book. Okay, so again in the book you will be having number of pages, right? Like this. So if you create a new project, that it is kind of a book. Again inside the book you need to start creating a pages, means number of screens you need to create. Okay, so first just I'll give you some steps. Okay, so just a second. Means the steps to create a SCADA project. Okay, so first what you need to do, okay, so create a new project. Okay, just I'll zoom it. Okay, so view, zoom is there. Okay, first what you need to do, create new project. Okay, very important these steps are. Next step is, what you need to do, according to your application you need to create. Okay, sorry. Okay, so create. Okay, so required number of screens. Okay, next what you need to do, you need to create, okay, graphics. Okay, according to the field process. You can note it down. Okay, next what you need to do, so for like whatever the IOs you are having, for those things you need to create a tags. I will explain what are tags. Okay, create tags. Next, okay, what are the tags you have created, that you need to link okay, with the graphics what you have created. Link the tags or link the created tags to the graphic respective graphic elements. Okay. Next what you need to do is uh, you need to simulate it, or you need to run the system run sorry run and analyze the result. One more step will be there in between. Create tags, link the graphic elements and define. Okay, so it's nature of working. Okay, define uh, or like it's not needed, anyhow you will get to know. Okay, so these are the steps what you need to do. First you need to create a project. After creating a new project you need to create the number of screens required. Next you need to create the graphics. Next you need to create tags. I'll tell you what are all these tags. Next whatever the tags means, this is nothing but addressing. Okay, you have created that, you need to what I can say link with the graphical element. Next any process if you want to do like writing script and all, okay, all those things you can do. After that you can run and analyze the result. Okay, these are the steps. So next, so coming to like steps we got to know, now we will get to know what we need to do. Okay, so any basic SCADA will have two windows. Windows in the sense I told no, you will get to know if I explain now. Just keep it in mind. So any SCADA will be having two windows. First one is okay development window. Next one is runtime window. Okay. See name itself it is telling development window means so where a user can create his own graphics. Okay, means any edits you can do. Okay, so or like edit or deletion. Okay, all those things you can do in a development window. Okay, so development of a graphical user interface usually called as a development window. Okay, so after doing development and all, if you want to check the results, so what you need to do, you need to run your project. Okay, see, that is what your runtime window. Okay, so in runtime window only you can analyze the result. You can't do any modifications and all. Okay, again if you want to do modification, you need to come back for the development window, do the changes, again go to the runtime. Okay, means development window is for modification and creation of graphics, and runtime window is to analyze the results. Okay, fine. Next, in development windows we can edit delete, so that only like what I explained in development window. Okay, so we can edit delete the graphical objects, writing the code and user configuration, etc. Many SCADA softwares will provide the indefinite time for development of GUI for the trial version itself. Okay, in runtime we can only monitor and control, we can't edit the GUI. Many trial versions we have. So I hope you understood what is runtime and development. Okay, so what like SCADA software means so two types will be there. One is trial version and another one is licensed. Okay, license means there will be no restriction and all. So license in the sense, so you will be purchasing your SCADA based on the number of tags what you can create. Means tags in the sense it will be representing your IOs only. Okay, so like 32 or 64 or 128 tags like this license is going to like means you are going to define. Okay, so if you don't have license you can go with the demo version. Okay, but the demo version is having some restriction. Okay, so what are all those restrictions? See, once if you open the demo software means it will be open for only 2 hours. Okay, means soon after 120 minutes it will be closed, again you need to reopen. Okay, and the maximum number of IOs what you can define in the demo version is like 30 to 30. Okay, 30 or 32. Okay, so some of the softwares only 30 we can define, or some of the softwares 32 like this. Okay, so like these are the features of demo version. Okay, only open for 120 minutes and the maximum number of tags I can create is 30. Okay, fine. Next, like if I want to go for SCADA designing, what and all we need. Okay. So first we need tag name. So till now like we use the term, right? Tag name, tag name. What is the tag name? It's a name of a given, means it's a name given to the graphical object in the SCADA software. See, like a best example I'll give you. You have one uh, switch or a lamp in the field. Okay. So in SCADA that you will be representing in a like any format. Okay. So I'll take one graphical switch. Okay. How you will be linking that switch to what I can say this graphic. Okay. So by using this tagging. Okay. So just again I will open the notepad. Okay. See here. Uh, so here you will be having field device. Okay. So this is what field device. Next, so you will be having PLC here. Okay, next you will be having SCADA here. Okay, so in the field, means in the PLC, so just here it is for both. Okay, so I will be giving address. Okay, so if it is a input in the controller, means delta controller, if I take address is x0. If it is the output, means okay, I'll be addressing it as what, y0, like this. This is what address, and I'll be giving the comment for it. Okay, so let's take this I'm using for start. Okay, this is what comment. Okay, so if I go here, sorry. Okay, so this is what like a lamp kind of a thing I will give. Okay, see, this is what these two are comments. Okay, so tag name is something that, so here I'll be having. Okay, so it's graphic representation. Okay, so what I will do, I am going to create a tag name. Okay, that is linked with this x0. X0 means this tag. Okay, so here I'll write this, I'll write it as a switch. Switch is what, the tag name for this x0. See, x0 is a address, start is a comment, switch is a tag name for this x0. Now whatever the graphic I'll be creating in the SCADA, that is linked with this tag name switch. Okay, so graphic means switch, switch means what, x0. Okay, so similarly for output also, so lamp is there, that only you can take it as a comment also, or like some light kind of a thing I'll take. This is address, this is comment, this is what the tag name. Now what I will do, I'll create some graphic for that. Okay, so sorry, graphic for that. Okay, so tag name what I will give, I will give it as a light. So light means what, here y0. Okay, so this is what your tag name. Okay, so if I go here, tag name, so it's a name given to the graphical object which is representing your field device. Okay, see, we have several types of tag names. So mainly two types, one is user defined and system defined. See, now again I'll go with the same example. Okay, I have one switch, means x0. I can represent it, means I can call it as a switch also, or someone may call it as a push button, or someone will call it as a toggle switch. Like this, means that name is going to vary from one user to other user. Okay? That's what we are calling it as a user defined tag. Okay, so one more is also there, that is system defined tag. Okay, what is this system defined tag? See, like today is what day? I think okay, so what's the date today? Okay, so anything. Okay, so what's the year, like 2022? Okay, so like this means best example what I can give is, so any other name is for January. Okay, means January I can call it by the name January only. Okay, February I can call it with the name February only. So Sunday like Sunday only. Okay, so second means second, minute means minute, no other alternative names. Even if 100% is telling, they are going to tell it with the same name only. Okay, so like this we have some special tags which are system defined, which are defined by the system itself. So we can't change that one, modifications are not there, and those are only for that particular applications. Okay, we can't use it for the other things and all. Okay, that is what system defined tags. Okay, next there are some certain rules that we need to follow while creating these user defined tags. Okay, so what are those rules, we'll see now. Okay, fine, you can see the user defined tag. See, these are applicable for only user defined. So We are not having the authority to create any system defined tags. Okay. See, tag name should contain at least one alpha character at least. Okay, means basically it's a alphanumeric which consists of a character, number, and special characters also. So what it is telling, at least it should consist of one alpha character, and it should start with character only, not with the special character and a numerical. Okay, and spacing is not allowed. Okay, so instead of that you can use the underscore. So these are the three rules. I'll repeat one more time. So it should start with the character always, and at least we should have one character, and spacing is not allowed. Okay, like this you can define. So this is about the tag names. Again we have integer, or what I can say, discrete type of user defined tag is there. Okay, that I'll explain you what are the different types. Okay, discrete is there, and integer is there, analog real is there, string is there, like this. Okay. So system defined tags, I already told. These tag names are special tags that they have a special meaning which you can't use for the general purpose. Okay. So they are always start with this symbol. Okay, like dollar day, dollar year, dollar time. Okay, like this. Next, again user defined tags. There are like different types of tags are there, as I told. Discrete. So switch comes under discrete. I can't like switch is 50%, 30% or 100 liter, like that I can't explain. Switch I need to explain always whether it is on or off, or 0 or 1, or high or low. Okay, that is what discrete. Next, integer. Okay, so which can go up to 32-bit length also. Say suppose if I want to define a speed, I can't tell it as a 0 or 1. So I need to define it as like 10 meter per second. Okay, 25 meter per second. Okay, like this. So that is what that comes under integer. Next I have analog. Okay, analog is for what? Temperature sensor or humidity measurement and all, because temperature means only we will not be having it is 10 degree, 20 degree, 30 degree, like that. We are having very high precision, like 10.015 degrees centigrade or 20.5, 20.23, like this. Okay, so which comes under analog, nothing but floating or a real value. Next one is string. String in the sense it's an array of characters. Okay, if I want to give any message, if I want to give any user ID or a password to the system, okay, then I can't go with this discrete integer or analog. I need, because I'll be having some characters. At that condition, I can go with this string. Okay. Next, examples of SCADA. Okay, so actually for this you need to know some other concepts, but I'll tell you. You need to know. See what happens. Software means like two instances will be there. One is interfacing with the real controller if you have the things means. Another one is simulation. Okay. So now first interfacing will keep it aside. Okay. First we'll go with the simulation. Okay. Again in simulation you will be having two types. One is with scripting and without scripting. Okay. So just I will open the notepad. Okay. See here I have. So real time or like interfacing I'll write better you can understand it. Interfacing with the real IO. This is one thing. Okay. Just a second. Instances. Okay. One is interfacing with the real device. Okay. Next what I have, if I don't have real devices and all, I should go with the simulation. Okay. Again under simulation you have two, means two instances. That one is with scripting. With scripting. Next one is B, I'll write it as without scripting. See, with scripting in the sense you can give some instructions. Okay, so scripting in the sense instructions you are able to give. Okay, so I'll show you the example. Without scripting means there you don't have means what I can say, the option to write script or some program or some instructions like this. Okay, so like you will get to know when I need to go with scripting and all. Okay, see now if I am going with the without scripting means without scripting in the sense I don't have the authority to write some instruction. Okay, at that condition how I will be linking my input and output means by giving the same tag name. Okay, here you can see. So input is some push button, output is some lamp. Okay, so these are linked with the same tag name. Okay, so now what will happen if I press this one? Nothing but, so switch I am making to high. Okay, I am giving logic high signal for this switch. So if this is on means obviously this will also becomes on, because I am linking with the same address. Okay, this method we will be following when we don't have an option to write the script. Why we need script and all we'll see in the future class. Okay, but just get to know, okay, these two methods. This is what without scripting. Next, this is what with scripting. Okay, so in SCADA different tag names you can see here. This is with respect to controller side, just leave it. Okay, but in SCADA, okay, see now if I press this switch, this bulb should be on, no? So this, instead of, because I don't have controller to write this ladder diagram now, but if I'm having scripting option means I'll be writing a script like this. If this is equal to 1 means light should be 1. Okay, or else like light should be 0 like NDF. Okay, this is what the script. So this is how we will be linking the IOs in the simulation. Okay, that too this is with scripting. Okay, and this one is without scripting. Okay, and this is how we are working with the SCADA. So applications of SCADA, like we are using almost in almost all the large scale industries like chemical, energy, food, beverages. You can go through with this thing, quite general. Okay, again these are the some of the application fields. Okay, so these are the assignments what you need to do. Okay, so before that, like this is about the SCADA. In the today's class, we learned actually lot of things. Okay, so starting from SCADA, what is SCADA? So we have seen some introduction. Okay, so before SCADA, what was there? What are like its advantages, disadvantages? Then we started with the actual SCADA system, advantages, disadvantages, and what are the different generations we have. Okay, and like what is there inside this SCADA means like feature, what makes this SCADA, what are the features of SCADA, that also we learned. Okay, next we learned okay, so this one, how, what is SCADA means like SCADA architecture we learned. Okay, so by using this diagram and all. Next we got to know what are all the protocols it is using. Next, what are all the different types of SCADA we are having, not types of SCADA, different brands of SCADA we are having. Okay, means what are all the possibilities, ways to communicate with the controllers, either it may be a same or it may be with the different brands. These are all about something drivers or a gateway. Okay, so next uh, this is about the general SCADA. Next we learn, so what will be there inside the SCADA software. Okay, and what is the tag name, different types of tag names, what are all the rules we need to follow. Okay, all these things, and different types of user defined tags, and how we will be doing the simulation in SCADA, that too with scripting and without scripting. Okay, and applications. So this is about the introduction to SCADA. Next class we will be learning. Okay, means we'll be starting with the SCADA brand, that is iFix. Okay, so thank you. So here I have some software link. I'll be sharing this PPT so you can go through with this. Okay, thank you.